All right, so I'm gonna ask for some help here, okay? Ready? Evan, what's the first thing I write? The very first thing I write for my process, like the whole process. Hold on 1 second. So if we're going through our problem-solving process, I've already in the step 1 for you. I've balanced the equation, right? What's the next thing I always ask you to write, just so everybody's clear on how to start? The question, which is what? So grams, right? Grams water. And what's the given? 1.0 kilograms of C57H1106. Okay. So if we write in the terminology that we're using in the BCE, it helps clarify things. So now, Evan, where do you want to start?
So we start with 1,000 grams.
So 1 kilogram of fat. Oh gosh, I've read this every time. Okay. So I'm starting with kilograms of fat, which you said convert to what?
1,000 grams of fat.
So where does 1,000 go?
On bottom.
So 1,000.
Wait,
No, yeah. Sorry, 1,000 goes on top. Grams. I'm going to just put fat for the moment because I don't want to write that again.
Wait, so we don't start with 1,000.
So technically you're starting with 1 kilogram. If you just immediately convert that to grams, like, I don't care, but I'm showing my whole thought process, okay? So 1 kilogram of fat is equivalent to 1,000 grams. Next step, Luke.
I then found the molar mass.
Okay, so what goes on the top here? Well, I know you found the molar mass, so the mass is in grams, right? So is that going to be on top or bottom?
Bottom.
Okay, so what's the molar mass of the fat?
891.501 grams.
Can I get some confirmation?
We just got 890.
So you did, so more specific. So around 891?
Yeah.
Okay, so I'm just going to not write the decimal for now. So that's the molar mass of this fat, and the molar mass means that's equivalent to what on top, everybody? 1 mole of this big, huge compound. And then, Nandika? Next.
Next I made a ratio, so on the bottom I put 2 moles of fat.
Okay, so we're putting our ratio right here. And where are you getting this 2 from?
From the coefficient of our ratio.
Okay, so 2 moles of fat, so 2 moles of C57H1106. I'm going to put fat for short. And then what's on top?
And then on top I put 110 for water.
Because the question's regarding water and the fat, so we don't care about anything else but those 2 numbers. So this is where we're now implementing our ratios. 110 moles of water. And Izzy, what's next?
You've lost me. I'm still writing.
Well, tell me where you're lost. So I think you actually did your process. You're just writing. I don't think you're lost. I think you're just writing.
I'm doing both.
Okay, then tell me what we need to clarify.
Okay, so I got like the ratio. I have no clue where to go now.
So think of I'm not going to draw the whole thing out because you guys have this in front of you. Where did we? I'm going to kind of go the same way I did last time. Where did we start on our mole map? On my side of here. Think about it. Started in the middle, right at mass, and we went to 1 mole of fat, and then we did what? We used the ratio to get 2 moles of what? Water, okay? It's one of these 3, right? We don't have the other row.
Mole of water on the bottom and 22.4.
No, the question doesn't ask for a volume.
Oh, it's mass, then it's the molar. Mass.
Yeah. What's the mole mass of water? So you said 1 mole of water on bottom, and what on top? 18.02 grams of water on top. Good. Okay, everybody calculate, and then if you we need to clarify, make sure we're all right together here. If you need to calculate, raise your hand. Nobody's calculating. Okay. That's because I left them out yesterday. That's actually why. Clean my room. All right, answer.
Hold on.
Okay, I'll wait.
1.1 times 10 to the third.
1 second. What did you say? No, this is the only given right here. We just use that right here. And then this helped us figure out where to stop. Grams. That's our question. Every problem you have one question and one given. Let me give you the whole answer before I round. Yeah. 1,400. Did I get 1,000? Oh yeah, 1,112. I got 12. Okay, so this is what I got in the calculator. There's exactly what's up here. Okay, so maybe so your number right there would be a little different than mine. So now how many sig figs do I need? 2 sig figs. So everybody, go. Actually, well, you were telling me this earlier. Good. So you could do 1100, so 1,100 grams, or that's equivalent to this in scientific notation, so that's the same. Okay. So if the camel wanted to make, so basically this was just a cool example because the camel's hump is not made of water. It's made of what? Fat, right? So this hump does not have water and it has fat in it. And the fat energy is used by cellular respiration and it combusts in its body, right? How do I know this is combustion? Not just because it's a hydrocarbon. I know it's combustion because of the presence of oxygen as a reactant, right? So it's combusting this, and it's making water in the body of the camel. Why would that be beneficial? Because they're in the desert, and so water, desert itself, it doesn't have no moisture around. So it makes it itself, and it makes that much water, which is kind of a lot. Cool example, Miss Owen. Thanks, guys. All right, so we're going to check homework from yesterday, lecture 1 and 2. Check yourself. A, B, C, D, and then A, B, C, and then we're going to do some other examples today. Okay, check with the person next to you as well. Yes, see, there's It's okay if we're close. Just make sure you're close. Yeah, is it C?
Yeah.
I just have to find my lecture. All right, guys, we're on looking at 2. Oh, I didn't put D up there, did I? No, I did. Okay, sorry. Looking at 2C, how many atoms? And it says atoms of O, singular O, right? Will be produced. Okay, so produced, does that mean reactants or products? Products. Okay, so products, right? So I know there's no singular O2 like diatomic oxygen products, but there is some oxygen in the products. Where's it at? In the carbon monoxide, right? So technically it's not just asking for just O. It actually wants you to find carbon monoxide first and then do the Reese cup example, right? Pull the oxygen out of the carbon monoxide. That'll be our final step, okay? So think about the O in the carbon monoxide, and that's kind of where we're going. But we're starting with what? So this is our given, 4.6 moles of silicon dioxide, okay? All right, so I'm to the magical unit of mole, right? I'm ready to cross the bridge. Where am I going to go? I'm going from silicon dioxide to which thing I care about? Yeah, I'm going from here to here. I'm going from silicon dioxide to the oxygen product, which is carbon monoxide. So what's this bridge? What am I writing here? So the mole ratio, right? So it goes on top. To what? Carbon monoxide, right? And what goes on bottom? 1 mole of silicon dioxide. Okay, so this gets us our 1 and our 2. Now I've already crossed the bridge. I've gotten to my mole ratios. Moles of silicon dioxide cancel. Now I can get to just singular oxygen. So, but I can't get there straight away. It's going to take me 2 steps. So I have to go from this carbon monoxide molecule to atoms of oxygen. So what do I need to get now? Use Avogadro's number to get to what? not to atoms, because this itself is not an atom. This is a compound, right? So first of all, what do I put on the bottom?
1 mole.
1 mole of what?
Carbon.
Carbon monoxide. And carbon monoxide is a covalent. Formula units ionic molecule. Okay, so I'm getting to simply molecules. So this is Avogadro's number 6102 times 10 to the 23rd molecules of CO. Okay, so now we pluck one little molecule out of it. We look at one molecule. What's in it? One of these molecules has what in it?
1 carbon.
1 carbon atom and 1 oxygen atom. So then we can go 1 molecule of CO has what in it? 1 atom of oxygen. Right. So when you write molecule and atom, it helps me see that you know the differences between those 3 particle types. So as we went, moles of silicon dioxide cancel, moles of carbon monoxide cancel, molecules of carbon monoxide cancel, leaving us with atoms of oxygen. Who got this? A couple of us. Okay, good. This is that Reese cup example. We're not really 2 Reese cups anymore, but it's just one thing inside of one other thing. Okay? All right, so debrief for the person next to you. You got 30 seconds to ask any questions you need to on homework, and then we're going to move on. Okay, so whip out that mole map for me. We're going to add one more piece to this. I have jokes all embedded. Okay, so everybody eyes up. Let's go. Eyes up. Which of these 4 have I not touched yet? Volume of a solution, right? Well, we already know about volume. Like, what number comes from anything of volume? There's more relationships, people. Okay. So, but we have our nice baseline. We know a lot of stuff already. There's one extra thing. So, when I say 22.4 liters, what am I talking about? Volume of a gas, right? It's very, very specific. So, if you need to highlight or star that, this is of a gas, right? So, if I'm not talking about gases, I shall not use 22.4 liters. If I'm not talking about gases, cannot use that number. So, the only other time we ever have volume is when we have liquid volume, like solutions, like we put 2 solutions together. So we have to have another way to talk about volume, obviously, because I can't always be dealing with gases. So this is the other volume situation. It's called molarity. What's it called? Molarity. So it sounds like there's something embedded, right? Mole is embedded. So molarity is actually moles. Not arity, moles per 1 liter of, not a gas, of what? A solution. Very close. Okay. So molarity, anytime you ever see molarity, it actually is referencing a fraction. It's referencing 1 or some number of moles per liter. So the other way to signify molarity is a capital M, not a lowercase m, a capital M. Okay, so you're adding this, you're elaborating on your mole map with me, yes? You are now? Okay. I don't always want to tell you what to do, but you should elaborate on your mole map, okay? So if I give you an example, like 3, have you guys seen this on my solutions? This is like 1 molar, like 1.0 molar sodium chloride, or 0.5 m sodium acetate. So there's been this in front of you, you just never really realized what it was. It actually is a concentration. Like if I had Kool-Aid that was super, super concentrated, with sugar and flavor and all that jazz, it would be like 10 molar, super concentrated. But if I had really crappy, like, light Kool-Aid, it would be like 1 molar. So the concentration is just how much stuff is in it. So if I had like a 2.0 molar solution, that means the 2 goes with the moles, so that's 2 moles, over 2 divided by what is 2? 1 liter. So 2 moles of substance, I'm going to say 2 moles of sodium chloride. So that's 2 moles of sodium chloride in 1 liter of solution. Okay? So basically what I have given you is a conversion factor. Molarity is just a conversion factor. That's it. Who saw some of this on their problem set? Like number 3, right? The bottom number 3 requires you to do this. Okay? So after we practice in class, I'll have you guys do one practice by yourself, and then we're going to start problem set. Okay? Because I can answer questions in class for that. Alrighty, you ready?
No.
Okay, almost. What questions do we? This isn't like you don't fully understand what this means yet. I have to apply it. Sometimes just basic memorization is not really all that important. We have to apply it to understand it. All right. So what is molarity?
It is the concentration of a solution.
Concentration of a solution, but it means whatever what?
Moles over the.
Okay, so stuff over a volume, moles over the volume, and the number that it's given is always representing the what? The number given for molarity always represents which side? Moles, and we always regard that per 1 liter, not just saying liters, 1 liter, okay? So if I ever wanted to get, let me write on this side, if I ever am given both molarity and volume, what I do is, remind me one more time, what are molarity's units?
Moles over liters, 1 liter.
Moles per liter, right? Okay, so I have some number of moles per 1 liter. If I'm ever given the molarity and the volume of a solution, let's say I give you 100 milliliters of solution. Notice there's no milliliters here, right? So immediately you convert that to what? Liters. Okay, so what's 100 milliliters equivalent to? Say again? 100 milliliters is, okay, King, I don't want to write this again, but we can. King Henry died by drinking chocolate milk. Base is liter, right? 1, 0, oops. If I can align this would be great. There's 1,000 milliliters, right? 1,000 milliliters in a liter. So how many liters is this? Okay. Talk to the person next to you. Please talk to the person next to you. I'm not reteaching that part. Talk to the person next to you. 3 that way.
That's what I meant.
Okay, can we come to a consensus now? How many liters?
0.1.
Okay, so we're bouncing this one back. 1, 2, 3. Woo! 0.1 liters. You are squirty. Okay. So we are now going to convert moles. So moles per liter is molarity. If I have molarity and volume both given to me, I can use them collectively together. So if I multiply this by 0.1 liters, what unit can cancel? Liters. And by golly, I made it to moles, didn't I? Because now the mole is the only thing left, right? And once I'm into moles, I can go anywhere. I can go to grams and go to the other form of liters, or I can go to Avogadro's number. So molarity is just another way to get us to moles, which is why it's on your mole map. Okay? All right, now we're going to apply this. I'm going to keep repeating this over and over, and you'll get it, okay? Yes. Let's go to 3. We didn't do 3 yesterday. Oh, does anybody get this? It says HG. Come on, guys. He's a rock. Thank you, Freddie Mercury. Google it later. Google it later. Okay. So consider, here we go. Write this reaction down. Consider the single replacement reaction between magnesium and copper 1 chloride. Magnesium and copper 1 chloride. Mackenzie, get me started on this reaction. CuCl. Beautiful. Stay like that, right? Because copper 1 means copper 1 plus, and what's everybody, what's chloride's charge? And you're not just memorizing. I mean, maybe you are at this point, but you have a periodic table in front of you, and no one expects you to memorize periodic table. Okay? All right, so Emily, it is a single replacement reaction, right? So what do we access? What do we have to look at first to make sure this reaction is going to occur? Okay, so everybody, so what are we looking at for that? Emily. You guys have any? So, it's on the floor. So looking at the activity series, everybody, where's magnesium? Is it higher or lower than copper?
Low copper.
Okay, so magnesium's high, copper is low, so is magnesium going to be able to scooch that copper out?
Yes.
Yes, it is active, so who does magnesium get with now? So magnesium chloride, is this magnesium chloride? No, what did I not do? Cross charges, okay, so MgCl2, and then who got booted to the cold? Copper, okay, balance the person next to you. Where do I need it?
Oh my
Is that
god.
good? Okay. Okay, so we have made the first step happen. We have a single replacement reaction and it's balanced already. Done. Now I could label like solids and stuff, but no, we're good. All right, so A. If, now listen as we read. If a volume of some molarity of copper 1 chloride is reacted completely, how much copper will precipitate? Okay, so from that, what have you gleaned? What was this first thing given to you? Okay, well, it's a volume though, right? It's a milliliters of a solution, right? Not just talking about gas, it's of a solution. I'll put B solution there, okay? And this is a molarity, aka concentration, so I'm just going to put big M there just to identify what is given to us. Blah, 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 blah. How much? What does this mean? So the question is grams of copper. Okay, that is what we want at the end. But I have two pieces that go together, these two pieces that go together, and that's going to give me my starting point. Okay, what did I tell you to do if you're ever given molarity and volume?
One on top of the other.
No, not ratio, not one on top of the other, but you're right to split the units if that's what you're thinking. I have to make this into liters first, and then what I do with them collectively.
The liters cancel out the liters on the.
So you're telling me to multiply them?
Yes.
Yeah, okay. So you're going to do M times V to give you moles. This is always the process if you're ever given molarity and volume. When you multiply them together, they will give you moles. But like Izzy said first, they have to be in liters because molarity is whatever what. Moles over liters. Okay, so I'm going to take, let's take 500 milliliters to liters now. So 0.5 liters. And we're backing the decimal up 3 places because there's 1,000 milliliters in a liter. We're going to multiply that by, I'll just kind of do the whole process in one. Multiply that by this, but this means how many moles? How many moles does this mean? The number is the mole, right? So 0.40 moles per 1 liter of solution. So this guy right there, 0.40 molar, means 0.4 moles per 1 liter. That's what that means. Okay, what cancels? The liters of the solution, good. And I did not write the unit or the identity. What is this talking about?
Copper chloride.
So CuCl, right? So this gives us, you guys calculate or do this in your head. So 0.5 times 0.4 is 0.2. That's our moles. Now,
Does it have to be?
oh yeah. Is it 0.40? No, it's only 2. 0.40. Okay. So everybody look at your mole map. With the person next to you, I want you guys to point where we are on the mole map. I'll just verify we know where we're going here. So I want to see, okay, so most of us are pointing at what? No, where are we at right now? Moles of what? Moles of X. We're pointing to moles of X on X. Now, where do we want to go? Well, in the final process, we want to get to moles of, or grams of Y, right? So, everybody's pointing at moles of X. Where are we going to go next? Moles of Y. After we get to moles of Y, what do we have to do next? Grams of Y. So, 2 more steps. Ready? So, follow through along on your mole map if it helps you. If not, if you've got it all up here, you're good. So, this is moles of copper. I'm basically taking this and starting my process like for reals, you know, okay? So, moles of copper 1 chloride. I don't care about copper chloride anymore. I care about just straight up copper. I just hid my ratio, didn't I? What is the ratio between copper 1 chloride and copper? Everybody, that's 2 to 2. So those are the two I'm concerned about. Stack them here. So who goes on bottom? Copper 1 chloride. And who goes on top? Just straight copper, right? Now, moles of copper 1 chloride cancel. What's the next step? Who goes on bottom? Moles of copper goes on bottom. So that's 1 mole of copper, because everything molar mass wise is just 1 mole. And what goes on top? What's the molar mass? 546. Okay. So 63.55, 63.546, whatever floats your boat. Moles of copper cancel, and we get. Everybody should be calculating with me, so if I holler at you, you can help me out. You got me, Grant? Almost. Anna, you got me? What's the answer? Oh, okay. Got me, Grant? So 12.71 is the answer before we consider sig figs, right? So consider sig figs for me. 13, right? Because there's only 2 sig figs in our initial information given. So 13 grams of copper. That's a lot of copper, actually. Okay. What's up? I got 12.7.
0.2 times 2 times 62.
Divided by 2.
I did not set it.
There you go. Okay. All right. So that's the only new thing we're really talking about today is the molarity aspect. Okay. We'll do some more calculations and then make sure that we're clear on how to consider this in a real situation with percent yield and stuff like that. Okay. All right. So next one, B. What is the question?
How many molecules?
Okay. So pause. So question mark molecule mg. Right. Okay. Blah, 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 blah. What's the piece of given information that would be us considering our starting point? 102.0 grams magnesium. Copper chloride. Copper 1 chloride. These are formed, but we're going with this. Okay. So this is our starting point, right? No molarity nonsense here. Go with the flow. Solve. That's where we are. This question doesn't do that. I don't know why it says molecules. I just said that to myself. It says it means atoms actually, because magnesium is not a molecule. So that's actually atoms, because magnesium is not a molecule by any means. What's the molar mass of copper, 1 chloride? 98 point what?
999.
It's cool. We're going to be more specific than you guys. Alright, and drum roll in 3, 2, oh, what did I do? 1. Alright, answer.
6.
8, 9 times 10.
Hold on. Did anybody else get 6?
Hold on.
Not. Double check your calculation. I think you multiply by 2 and that's divided by 2. Double check your calculation.
Oh, that's actually double check.
No, double check.
Alright.
And go.
3 point.
Yeah. Okay, 3 point.
1, 0,
1, 0,
1
1
times
times 10 to the
23.
23rd.
Oh, I got that.
Okay. Atom, not molecules, my bad on that, of magnesium. It is, right? Yeah, it is. Say again? Because, my bad, magnesium is not a molecule, that's a particle type, that was wrong, so I changed it to atoms. Okay, I'm not going to do the last one right now, okay? I'm going to practice another molarity one. Look at the U try 3. U try 3. Oh, no, I have like 1 or 2 extras. So can you, I'm going to scroll to that one. Oh, I have more jokes. Exothermic reactions, I studied them before they were cool. What does that make sense? It released energy and it's cold. Okay. And then, actually not 3, 4. Go to U try 4. Okay, we're going to do this one together. But I want to let you start on your own first. You can do the same paper somewhere, that's fine. I'm just going to let you start without me first. So start balancing. You try 4.
Is it too late for the shot?
So using charts now. So it's balancing reactions.
It's sodium sulfate.
Like, and then it's barium nitrate. Where's barium? Here next to it. Sodium sulfate and barium nitrate.
Write down the 2 reactants. Oh, yeah, I'm not your colorist.
Oh, I didn't even see that. I was right there.
Okay, so there's 2.
Sure. Oh, yeah. So what are we doing?
At least I know one.
Actually, this is the one where you
What church is my church?
So if it's double,
barium nitrate is
Who's on A? Who's progressing through A? Okay, I don't want to talk to you yet. I'm doing slowly putting some pieces on the board. So start by writing your given That's why we write down examples. You can go back and read those references. Alright, a lot of us are progressing on. I'm going to just ask for some feedback here, okay? When you are given volume and molarity, what do you have to collectively do with them? Multiply them. Because remember, if you did not write this down, hold on, I know you're talking, just hold on. If you did not write this down earlier and put a big O star by it, whenever you have M and V, you have to multiply them to get moles. It's the only way you're going to be able to start the problem. You have to get to moles because that's what's on the mole map. Then you can go anywhere from there. So how did we multiply these together? What do we do with the milliliters first? Easily just converted that to liters, which either you could write it out like this, 120 milliliters in 1 liter, there's 1,000 milliliters, right? So how many milliliters, or how many liters is that? 0.120 liters, and then you say, okay, liters is volume, I have to multiply that by molarity, but what's molarity broken into the two units it exists as? Alright, so we're going to multiply that by, what goes on top? 0.010 moles of what? Na2SO4, okay, so that's what this 0.01 molar is referring to, but that's per what? Divided by what? 1 liter of, and I'm going to put SLN, so solution again, so we remember we're not talking about gases, we're talking about solutions. Okay, so then now, I just literally converted to liters, which you could have done in your head. The liters cancel with these liters, and I get what? How many moles? Point 0.0012. No, it's yeah, 0.0120 moles of sodium sulfate. Good? All right. Excuse me? I don't think you need to. Not sodium sulfate. Okay, hold on. So I did not read the whole question, but I did know that you had volume and molarity that needed to be multiplied that give you moles. Now when you read in the question, it says how many grams of precipitate will form. We never even found the precipitate, right? Did you guys?
Yeah.
Okay. So what did you look at? Just verify we're all clear. solubility rules, and you looked at sulfates and nitrates. All nitrates are what? Soluble, so you said, I'm not even looking at nitrates, okay? And then you looked at your two sulfates, and this is the product, right? Sulfate is in the which category? In general, soluble category, but then the exception was what, Austin? The exception was barium, so that's going to be our precipitate. So that means this question is technically asking for grams of barium sulfate. Okay, that's our question. We have to connect sodium sulfate to barium sulfate. What's the connecting piece?
Their ratios.
Which is what? 1 to 1, right? So I know it's 1 to 1. You're like, that's not going to change my numbers at all. But if you don't write it, that the process is wrong because the process requires you to cross the bridge. It means the mole ratio. So what am I doing next here?
You put 1 mole of sodium sulfate on the bottom.
And this 1 mole is coming from
The
this, right? Okay.
and then you
And
put
this
1 mole of barium nitrate.
or barium sulfate, right?
Oh, yeah.
Because we're going to the precipitate.
Yeah.
Okay, so I have to get the BCE with the ratio to get that. And then now we have went from 1 mole to the other moles. Now it's my last and final step. Go to grams. I heard somebody say go to grams. What up at grams?
On the top.
On the top, so what's the molar mass of barium sulfate?
233.4.
200 what?
33.4.
233.4 grams. So you added up barium sulfate and 4 oxygens, and that's for every 1 mole of itself. Thank you. I know these get tedious, guys, but we're just going to try to hit out one more here. And then we need to multiply across, and we'll get our answer. So 0.28. Sounds about right. 0.2. What was it before rounding? You look at it. Oh, okay. So 0.28008. So 0.28 is going to be our final. Okay. So I know it's tedious, but I want to know out of 1 out of 10. Now let's do thumbs up. So I'm great at stoichiometry. I can rock this. I'm getting there. Or what is stoichiometry? Just do it right here so I know. You don't have to advertise it still. It's just for me. Okay. So I'm just going to show you one more style of the molarity where the question's just phrased differently, and then I'm going to work with some individuals, and we're going to start some homework in a second, okay? So the last question on, I think it's C. Nope, lies B. Let's do B. Notice the question is just a hair different. What makes it different? It asks for the... We haven't solved for volume yet, right? We haven't solved for milliliters of stuff. So I just want to make sure you're clear on how to do this one, okay? So let me get you started. I mean, let you get started. So what am I doing first?
We're going to convert the milliliters to liters.
Yet again, right? So we're going to get milliliters to liters, and then we can do what?
We can figure out the molarity.
So using the molarity, we're going to do what with it, Evan?
We're gonna multiply liters.
Times molarity to get to what?
There you
To get to what?
go. Moles.
Okay, so we're doing this step again, right? Molarity times volume gives us moles always. And then we're going to do something else at the very end. All right, so you guys got me. So 50 liters is milliliters is how many liters? Loud and proud. 0.05. I'm going to keep my sig fixed. I'm going to keep my remaining zeros there. 0.05 liters. Thanks, Emma. We're going to multiply that by what? Hi.
Sorry, I'll come back later.
Do you need Chem Club stuff?
Yeah, my name isn't on the sheet.
Put your name on the bottom. I remember that, yeah. All right, so 0.01 moles of what? Hey, back with me.
It's
Moles of what?
0.0.
Sodium sulfate, right?
Yeah.
Just making sure we're here together. And remember, molarity is what per what? Moles per what volume? 1 liter. This is always moles per 1 liter. Okay, so liters cancels, and this gives us what? 0.
0, 0, 5.
Oh, I don't like that. I'm gonna go scientific notation. Thanks. 5.00 times 10 to the negative third. Oh, sorry, that is fourth. Sorry, human calculator occasionally fails. Okay. So now we have moles, and we can conquer the world with moles, right? So starting with moles, what is this question actually asking about? Volume of what?
Barium nitrate.
Of not just barium nitrate, but 0.01 molar barium nitrate. So the funny thing with that is, I told you molarity is 2 units, right? It's a conversion factor. And what can you always do with conversion factors if you have to? I can flip them. I can go up, down, whatever. I can flip them if I need to. So write out just to the side someplace what barium nitrate's molarity is. It's how many moles? I heard somebody say 0.1, or is it 0.1? 0.01, right? Per what?
1 liter.
Molarity is always moles per liter, right? So this is per 1 liter. So if I have this, I could easily just say, okay, well, I could just flip that if I need it, which I might, and put what on top? 1 liter, and what goes on the bottom? 0.01 moles of barium nitrate. Okay, we are going to have to flip this. This is what I'm telling you now, okay? So utilizing this mole, and I'm just going to rewrite it just so I can have it all together. 5.0 times 10 to the negative 4th moles of sodium sulfate. What do I have to do next if I have moles of barium sulfate, Austin?
Cancel out. Or cancel out the
Sodium sulfate, right? So what am I accessing for that?
the ratio.
What is the ratio between sodium sulfate and barium nitrate? It happens to be 1 to 1 again, right? So we're going to use the 1 to 1 and show our work with that. So what goes on bottom?
1 mole of
Sodium sulfate. And what goes on top?
1 mole of barium.
Okay, so now I have moles of barium nitrate on top. The question's asking for milliliters, which means liters, and I can just convert to milliliters at the end. So, does anybody want to tell me what I potentially is gonna have to cancel?
The mole.
Gonna have to cancel moles of barium nitrate, right? And I gotta get to solution. So, Aaron, do I use this version or this version? Why this one? Because moles is on the bottom, right? So I'm using the molarity as a conversion factor. So I'm putting 0.01 moles of barium nitrate on the bottom and 1 liter on top. And just because it's asking for milliliters, I'm going to have to do one more step. 1 liter is 1,000 milliliters. And that should be 5.0 times 10 to the negative 2nd. Nope, sorry, times 1,000. My bad, times 1,000. 50.
Yeah.
50 milliliters of barium nitrate solution. Oh my goodness, pat yourselves in the back. We got that done. Okay, take a breather for a minute. I am going to ask for some folks to grab laptops if you don't have your problem set printed. Okay, if you don't have your problem set printed, grab a laptop. Get a walk break in. Get a walk break in. We'll jog. Breathe in some oxygen. Spare your time. Just as long as you guys are on to the left, right here. What? Who knows what? Okay, Okay, so I see you yawning. Get some sleep tonight, because tomorrow we have one more kind of lecture day, and then we're done with Stoichiometry. Okay. So,
We don't allow reading.
well, I'm just requesting for tonight. You do.
Inform our other teachers.
Yes, I will. I'll send out an alert to entire classroom staff. My chemistry students need to sleep. Okay. So we have about 25 minutes. Let me tell you what I think that you're capable of doing, and then you can confirm yay or nay if that's possible. So, guys, the whining does not help. I don't know if you know that. It doesn't. Okay. So I was gonna do two more slides of notes, but I'm gonna hold those for tomorrow so that we can get some questions in and get some practice. On problem set 12, give me a thumbs up if you've already done one. The true false you should be able to do on your own time. Please do not waste my class time doing true false. 1, you guys can write mole ratios. 2, you're in from moles to moles. Check. How many steps is that? 1, how many steps is B? Grams of aluminum to much aluminum oxide, sorry. So you're going from grams to grams to not grams to grams. Grams to moles. Moles to. Alright, I'll let you guys figure that out. You guys can almost do everything here. The only thing you cannot do is anything that says limiting reagent. So if it says limiting reagent, do not do it. We're learning that tomorrow, okay? I'm gonna leave that up here. You guys can work together, but no music right now because I need some of you guys to be able to ask me questions, and then I'll let you know. Okay? Yeah, work together, guys. I'm coming around to help you when you need it, but it's gonna depend on you. And I'll put it in your flip bag.
It's probably the same question. Instead of problem.
Thank you. You don't need any distractions.